On page 61, 1b, they want us to find the range and the interquartile range. So the first thing we've got to do is we've got to rank this data. We've got to put it from smallest to largest. And then what we're going to do is find the range, because that's just the high value minus the low value. In this case, 37 minus 2 is equal to 35. Then we want to find the interquartile range, which is Q3 minus Q1. So we've got to find the quartiles. Keep in mind we got n equals 9 pieces of data. So the fifth piece of data is going to be the median. And quartile 1 is going to be the median of the lower half, and quartile 3 will be the median of the upper half. So now all we've got to do is find those. They're both even, so we're going to find the average of those two numbers. And then all we've got to do to find the interquartile range is going to be to subtract them, and we'll get an interquartile range of 20. Now in part number 2, they want us to also find the range, interquartile range, but they give us a box and whisker plot. So the range, we got to figure out what these numbers are. In this case, you'll notice that there are 4 boxes of 5 that make up 1. That means each box is 0.05. So I can use that information to figure out the high is going to be 3 plus there's 14 boxes. So that's going to be 14 times 0.05. And then the low is going to be 18 boxes. That's going to be 8 times 0.05. That's going to give me these two numbers here, and the range is going to be 3.7 minus 0.4, or 3.3. The interquartile range, we're just going to find Q3. That's where this box ends and where it begins. And so I take a look there. Q3 is going to be 2 plus, looks like 18 boxes. It's 18 times 0.05. And that's going to be a 2.9. And then Q1 is going to be 1 plus 3 boxes, or 1.15. And when I subtract those, I'm going to get an IQR of 1.75. Now, part B says, what would you expect the skew to be? Well, the median is over to the right-hand side. That means it's going to be negatively skewed. In this case, the mean is going to be less than the median. Let's look at problem number 3. Number 3, we've got the STEM diagram here. We've got 15 students, and they want us to figure out the range and the interquartile range. So all we need to do that is find the high and the low value. The high value is 50, the low value is 9. It gives us a range of 41. Interquartile range, I need Q3, and I'm going to take away Q1. So Q3 is the median of the lower half, so I've got to find where the halfway mark is, so I've got to find the median. Since there's 15, we're going to use the 8th for the median, that's 37. And now I can go and look for my median of the lower half, which is going to be out of these lower 7 pieces, so that's going to be the 4th piece, so that's going to be 28, that's Q1. And then I'm going to go up here for the top 7. I look for the 4th piece of that data, and that's going to be, let's see, 46. And see, now to find the interquartile range, all I do is subtract them, and I find out that it's 18. In part B, they want us to make a box and whisker diagram on graph paper. So we need the minimum, we need Q1, we need Q2, we need Q3, and then we need the maximum. In this case, our lowest value is 0, and we go up to 50, so I'm just going to go by 10s here, skipping a box, so actually I'm going by 5s. And now all I got to do is plot my points. I've got 9, and I'm going to have 28, and then 37, and then 46, and 50. And all I've got to do is put a box around Q1 and Q3 and a line through the median, connect the whiskers, and then I've got my box and whisker plot. The last thing I should do is I got to make sure I label the scale. This is marks out of 50, and I'm in good shape. Okay, so let's take a look at the next one. Number 4, they give us a back-to-back stem and leaf diagram, and then they basically want to know whether it's true to say whether fouls in the 2 sports are equally varied. Well, there's 2 ways we can measure variation at this point. We can look at the range, or we can look at the IQR. Keep in mind, later we're going to look at standard deviation and variance, but right now that's all we've got. So hockey, let's spell it out. There's 8 pieces of data. We can figure out the Q2 is going to be the 4.5. It's the average of the 4th and the 5th. So that means it's going to be the average of 16 and 18, or 17. And then Q1, that's the median of the lower half. Well, there's only 4 of them. That's pretty easy to figure out. So that's going to be the average of 12 and 14, which is going to be 13. And then Q3 is going to be median of the top 4, and that's going to be the average of 19 and 21, which is going to be 20. And so if I want to figure out the IQR, all I do is take 20 minus 13, and I figure out that it's 7. And the range would be 24 minus 4, or 13. Now for football, we've got the same kind of basic setup. We've got 8 pieces, so we already figured out most of the stuff. We know the Q2 is going to be the average of the 4th and the 5th. That's going to be 20. Q1 is going to be the median of the lower 4. That's going to be 18.5 in this case. Q3 is going to be median of the top 4, which is going to be 22.5. And then all I got to do now is subtract those for my IQR. That's going to be 22.5 minus 18.5. That's going to give me a interquartile range of 4. And then the range is going to be 13. So basically, if we're looking at the range, it appears like they both are equally varied. But generally, the IQR is considered a better measure of variance. And you can tell that in this case, that football has got a lower variance than the hockey. Okay, let's check out the problems on page 69. Page 61, number 1, they want us to find the mean and the standard deviation for the set of numbers. So the mean, that's the sum of all the x's divided by the number of x's. In this case, that's going to be easily figured out if I just use my calculator and I do menu 6, 1 variable statistics. If I enter in each of these pieces of data, then what I'm going to do is I'm going to push option, and it's going to give me the choice of 1 variable calculations, and then it'll show me all the different calculations that I need. You'll notice it gives me the sum of all the x's, 300, and of course I can tell that the number is 8 for n, and then all I got to do is divide that, but it's already on the calculator, 37.5. That's my mean. Now, if I want to find the standard deviation, I'm going to use this formula here, which is going to be the sum of all the x's squared divided by n minus the mean squared. And all I'm going to do now is show that I understand the method. I'm going to write down all my data points squared. I'm going to divide them by the number of data points, 8, and I'm going to subtract the mean squared. This is actually the variance, and then if I go to my calculator, I'm going to be able to find out what all this information is. The sum of all the x squares is 12,478, and of course is 8, and then the mean is 37.5. If I take the square root of that, that's going to be the standard deviation. And I can actually do these calculations or just look at the calculator, but it's going to be 12.4 to 3 significant figures. Okay, let's look at the next one. On problem number 2, they give us these 3 sets of data, one for biology, one for chemistry, one for physics. They want us to find the variance. Well, first we're going to need to find the mean, and that's just going to be 21 plus 33 plus 45, all divided by 3. So that should be simple enough. Actually, these are such small numbers, or small number of numbers, it doesn't even make sense to put these in the calculator, using the statistic function. Anyway, the mean's going to be 33. And now I'm going to find the variance. The variance formula is going to be the sum of the x squares divided by n minus the mean squared, which all I've got to do now is take that same kind of thing that I just did, only square those x's and divide by 3. And I'm going to find out that I'm going to get 3,555 divided by 3 minus 33 squared, and then the variance is going to be 96. And I'm just going to do the exact same thing for these other 2 subjects. I'm going to do it a lot quicker, and you're going to find out that the variance is going to be the same thing for all 3. Anyway, it's good practice to use the formula. That's why I kind of like this problem. Anyway, let's move on to the next one. In problem number 4, they give us this table that's got 360 pieces of data on it. The sum of the F's frequencies is going to be 360, and they want us to calculate the mean and the standard deviation. Alright, so if we know that n is equal to 360, that's good, that saves us a little bit of work. And to find the mean, we're going to take the sum of all the x's times their frequencies and divide by the sum of the frequencies. It's going to look something like this. And when I get that, I'm going to find out that the mean is going to be 2. After I've done that, I'm going to go ahead and move on to the standard deviation. Standard deviation I'm going to do the variance, because that's going to be the x squares times f divided by the sum of the f's minus the mean squared, because then all I got to do is the square root. It's going to look a lot like we just did a minute ago, only the x's are going to be squared. And when I do that, I'm going to find out the sum of the x squares times their frequencies is 1,672. So now all I got to do is set up my formula, plug in the information I know, and then put it in the calculator and figure out what it is. And the nice thing is the calculator has got it set up. Let's go back to the calculation, and if you take a look at that key right here, square root, and this is a fraction key, I can make this look exactly like what I've written on my paper. And then I find out that the standard deviation is 0.80277 or 0.803 to 3 significant figures. Now I can go to the calculator and I can use the statistics function, menu 6 and one variable, and plug in this data that we've got, and then just check the check the calculations and find out that the mean is 2 and the standard deviation is 0.80277. So I feel good about that. All right, let's look at the next part. It says find the interquartile range and give an example of what it tells about the data set that the standard deviation does not tell us. All right, so let's go ahead and find IQR. That's going to be Q3 minus Q1. And I've got, let's see, 360 pieces. So that means it's going to be 361 divided by 2. And that's going to tell me that I'm looking at the 180.5th piece of data. Well, if I look at the table, that piece of data is clearly going to be in the class with a 2. So Q2 is 2. Now Q1 is the median of the lower 180. I can do the same thing, and I find out that I'm looking at the 90.5th. Well, that's clearly also in the category of 2. So Q1 is 2. And then I look at Q3. Well, that's the median of the upper 180. If you look at the back half here, you'll see how it's got 81 and 80. That's 89. Well, that means that the 90th is going to be inside the category 2. So it looks like Q3 is also a 2. And so what makes this a little bit weird is that the IQR is going to be 0 because 2 minus 2 is 0. Basically what we figured out is that the middle 50% are the same in this particular data set. Let's look at the next one. In problem number 6, they want us to find an estimate of the standard deviation given this data set table where the data has been grouped. So we know that the sum of all the f's of the frequencies is going to be 50. They tell us that in the problem. Let's write down our formula. It's going to be the sum of all the x squares times the frequencies divided by the sum of the frequencies minus the mean squared. Now the problem is, because it's group data, well, we're going to have to use a mid-class value to represent each group. And we're going to find the mean first by taking each mid-class value times its frequency. So of course we've got to find the mid-class values. And all we're doing is taking the boundaries and adding them up and dividing by 2, just an average. So for example, 30 plus 37 divided by 2 is 33.5. That's the last mid-class value. So anyway, now I'm going to show my method here where I'm going to write down what basically I'm going to do is it just means I'm taking each mid-class value times its frequency and then divided by the sum of all the frequencies, which is 50, and then I can figure out that the mean is going to be 23.02. Let's go ahead to the standard deviation. For the standard deviation, we're going to need the sum of the x squares times their frequencies, which it's going to look just like we did a minute ago, only we're going to square each x before we multiply it by its frequency. Now, you probably don't need to figure out all this by hand, but you do need to write it down to show your method. What I'm going to do is I'm going to use the calculator to show or to find these numbers. So anyway, if I go into 6 statistics and plug in this data, plugging in my mid-class values and then plugging in their frequencies, I can go and I can pretty quickly figure out all the numbers that I need without actually multiplying and adding all the stuff up. So you can see here that they tell me the sum of the x's, they tell me the mean, which we already figured out. The sum of the x squares is going to be 28,263. And now we just plug it into the formula. So let's see, standard deviation. Well, we got a square root of, we got 28,263. We're going to divide that by 50. And then minus 23.02 squared. Make sure we square root the whole thing. And I can put that in the calculator and just lay it out exactly the way it looks on my paper here. And that's going to be our solution, 5.944. And if you recall, the calculator we looked at earlier, that's what exactly it said. All right, for number 7, what we've got here is we've got a table, but it's not complete. In the frequencies, there's a constant k, and we've got to figure out what that is. And then we've got to figure out the variance. All right, so k is a constant, it's a number. We got to figure out what that number is. So when you think about this, they tell us the mean. So if that's what I'm thinking, I'm going to write the formula for a mean if I've got a frequency table, and that's going to be the x's times the frequencies divided by the sum of the frequencies, right? All right, so let's plug in the information we've got. Well, we know the mean, that's going to be 17, and we can go ahead and multiply all this stuff straight across and then divide by all the frequencies that are added up. Now I know it looks like a lot, but it's just an equation. Oh, and keep in mind it's equal to the mean, so it's equal to 17. So we can simplify the numerator by putting our k's together and our numbers together, and then we can simplify the denominator by doing the same thing. And now we just multiply both sides by 4k plus 23 to get that out of the denominator. And now this one side will cancel out, and all we've got to do is put our combiner-like terms. We got 30k and 16k and 17k. Add our numbers together. We multiply the other side. Now we've got this equation. I get the k's on one side, the numbers on the other side, and I find out that k is going to equal 6. So it was a lot of stuff, but really it wasn't all that hard. Just a lot of multiplying, adding, and subtracting. So I'm going to go ahead and update my table with the actual frequencies. And then what I'm going to do is get rid of all this stuff because we need more room to work to figure out the variance. To find the variance, what we're going to do is we're going to find the sum of the x squares times their frequency divided by the sum of the frequencies, and then we're going to subtract the mean squared, which now we can do since we actually have frequencies. Let's see, let's try doing the mean first. That's just going to be the sum of the x's divided by the sum, or the sum of the x's times their frequencies divided by the sum of the frequencies. And I'm not going to go ahead and multiply all this out. I'm going to do this in the calculator. But I do want to write this down to show that I understand the method for doing it. And I guess let's go ahead and take the calculator right now. All I'm going to do is go to menu 6 and then plug in this data and make sure I do it accurately and plug in the frequencies. And then I'm going to push option 3. And then it's going to tell me that the mean is 17. That's awesome. And it also gives me other information which I can use a little bit later. So now to set up the variance is going to equal the sum of the x squares times the frequencies divided by the sum of the frequencies. So let's figure out what the sum of the x squares times the frequency is. And I'm just going to write this down. And again, I'm not going to actually figure it out because it's in the calculator. All I got to do is call it up. And let's see, the sum of the x squares is 13,711, so I'm going to put that there. And see, now I've got the information I need for my formula. And so the variance is going to equal this minus the mean squared. And I can actually go in the calculator and look and see what the answer is. It's 2.723. If you don't trust it, go ahead and do the calculation. It's going to look like this. Let's get menu and then 1. All right, so let's use the fraction key, and we'll find out that it is going to actually be 2.723. All right, I hope that helped, and thanks for watching.